Welcome back. What do you think all these products have in common? If you guessed they all contain polyatomic ions, you'd be right. Bleach has the hypochlorite ion, baking soda bicarbonate, and Tums carbonate. Our job this lesson is to figure out how to write the names and formulas of polyatomic ions, like the ones you see here. Here's the first set you'll need to know. Before we give you some hints on how to learn them, let me share more practical examples. Nitrite is found in processed foods like hot dogs. Hydroxide in oven cleaners. Sulfites in wines. We could go on. Now, learning these may look intimidating at first, but don't worry. As I said, I'll give you some hints in a minute. And here's a few more you'll need to know. Notice the hypochlorite we saw in bleach. Even with the hints, you'll still need to put in a fair amount of time to memorize them. Think of it as learning the vocabulary of chemistry, just like you would for a new language. I recommend getting index cards. Use only one index card per polyatomic ion. Put the name on the front and the formula on the back. Then carry the stack of cards around with you to quiz yourself whenever you have a free moment. And here's a quick tip for you guys out there. You just watch. If you have a stack of study cards always on hand, it will really impress the ladies.
Surely you can't be serious.
I am serious. And don't call me Shirley.
Another option is to practice the Quizlets I made for you. You can find them on the chapter resources page. One final quick point before the hints which follow. Soon you'll hear the term oxyanions. That refers to polyatomic anions that have oxygen and one other element, like the one circled in red here. Okay, hint number one. Oxyanions ending in "ite" will have one less oxygen than its sister oxyanion ending in "ate." What does that mean? Well, let me get you started on this first problem. We need to give the formula of the nitrite ion. First thing I recommend is to memorize NO3- is nitrate. Consider the polyatomic ions ending in "ate" to be a good starting point. They should be memorized first, such as sulfate, phosphate, nitrate. Then recall that nitrite, because of hint number one, with its "ite" ending, will have the same elements, same charge as nitrate, just with one less oxygen. Therefore, the formula for nitrite is... Now, stop the video for a moment and fill in the blank with the correct formula. NO2 - 1. The only difference is that the sister anion ending in "ite" has one less oxygen than the one ending in "ate." Please try the next one in a similar manner. Stop the video now. Sulfite must have one less oxygen than sulfate, so we get SO3 2-. The charge doesn't change. On to hint number two. Oxyanions having the prefix "per" generally have one more oxygen than its sister oxyanion lacking the prefix, and those having the prefix "hypo" generally have one less oxygen. Per comes from hyper, which means more than. Just like if someone has hypertension, they'll have blood pressure more than normal. Hypo means less than. Just like if someone is hypoglycemic, they have less than normal blood sugar levels. To be clear, we need to say this hint generally applies, because there are exceptions. As far as you're concerned though, for all the ones you'll likely ever see, our hint does work. Consider this question, where we need to give the formula of perchlorate. First, put in the time to learn chlorate is ClO3 - 1. Remember, the ones ending in "ate" and having no prefix like per or hypo are worthwhile learning first. Then hint number two tells us perchlorate will have the same elements, same charge, just one more oxygen than chlorate. Stop the video for a moment and write the formula for perchlorate in the blank. It needs one more oxygen than chlorate, so it's ClO4 - 1. Next question. Fill in the blanks in the last two rows of this table. Try to do it without looking back at your list of polyatomic ions. Just use the hints. Stop the video now. Since chlorate has 3 oxygens and this formula has 2, hint number 1 tells us the one with less oxygen should end in "ite, hence the name chlorite. And for the last row, the prefix hypo means one less oxygen, so hypochlorite has only 1 oxygen, as shown. Time for your third and final hint to help you learn the polyatomic ions. Hint number 3 comes down to this. If the polyatomic ion name begins with the prefix bi and the charge of that ion is -1, then its formula has one more hydrogen than its sister oxyanion. The best way to clarify this is to go right to an example. Let's do the first 2 rows of this table together. If you've learned that carbonate is CO3 2-, then bicarbonate simply has one more hydrogen and a charge now of -1. The prefix bi in this case means one hydrogen was added to carbonate. And adding a hydrogen is really like adding a hydrogen with a +1 charge. So that's what causes the charge to go from -2 to -1. Don't miss that last point. When you add a hydrogen, you also make the charge 1 unit more positive. Now, this hint number 3 might be confusing because we generally think of the prefix bi relating to the number 2, not having something to do with hydrogen. In fact, the origin of the prefix did relate to the number 2. But for our purposes, it will be more useful just to remember the prefix bi means adding a hydrogen to a polyatomic anion that was -2 and is now -1. Bicarbonate, by the way, is also called hydrogen carbonate. Please complete the remaining blank in the table on your own. Stop the video now. So, bisulfate must have one more hydrogen than sulfate, and we adjust the charge from -2 to -1, and bisulfate is also called hydrogen sulfate. Now, before we wrap it up with some review questions, let me point out a possible misconception. One might think that because PO4 3- is phosphate, then HPO4-2 would be biphosphate. After all, we just added a hydrogen and adjusted the charge by 1. But it's not called that. Using the prefix bi, for our purposes, relates to adding a hydrogen to a polyatomic anion that was -2 and is now -1. The acceptable name for that one, by the way, is hydrogen phosphate. Last thing, please complete the table by filling in all the blanks. Don't refer back to the original list of polyatomic ions. Only use the hints provided here as needed. Stop the video now. This first one deals with the last lesson. Monatomic anions change their ending to IDE, giving us sulfide in this case. Since we were told that sulfate has 4 oxygens, then the sister oxyanion with 3 oxygens has the ite ending, giving us sulfite. Since we see chlorate has 3 oxygens, the sister oxyanion with 4 oxygens must then be perchlorate. Nitrite is the answer here for the same reason sulfite was the answer here. For these next 3, you would likely have had to look at the original list of polyatomic ions. For now, I did want to point out for cyanide and hydroxide, they are kind of oddballs in a sense, that they are the only 2 polyatomic ions you'll have that end in IDE. Usually when you see the ide ending, think monatomic ion, like the sulfide. Finally, since we saw before that this was sulfite, bisulfite must simply have a hydrogen added and its charge adjusted to -1. Well, let me know if you have any questions. Thanks for listening, and see you next time.